Hi everyone, it's Friday, the end of the week. Again, it's 5:30 where I am in San Francisco, but I've got to tell you, in all likelihood, I'm on a plane right now heading back to Montreal. I know I had to get to the airport for 5, so actually I'm probably in some line somewhere taking off my shoes, emptying my bags, and trying to explain why I carry so many computers. But enough of me. Let's continue our discussion of JDBC and specifically to take a look at the binary large and character large object types. MySQL, like many other databases, is capable of managing large blocks of text. Text that normally would exceed the capacity of a variable character, a varchar. In the case of MySQL, we can see that these blobs or, large objects fall into two categories. We have text and we have binary. Well, we have a tiny text. Not quite sure what I'd use that for. Next, we have a text. Now it starts to get interesting. A text field in MySQL can hold up to 65,535 characters. Same as for size for binary. Then if we take a look at medium, well, now the number is jumping, 16 million. And when we look at long, we're up to 4 billion in terms of the size or the number of bytes that can be stored. It's always an interesting question whether or not you should store binary data in a relational database. Some guidelines suggest that binary data should be stored in a separate folder and that you should only reference the file name in your main record. For our project, and just so that you gain experience in this field, I do want you to place your attachments into binary or character objects rather than immediately writing them out to files. So let's see how we can do that. Well, the first thing we'd want to do is insert, so we're going to need a table ready to accept a binary file. So you can see my create statement here. Right, create table binary files, my favorite primary key. Here we have a file name, and normally we do not include the path here, because where something will be stored eventually isn't the issue. We just need to know what the name of this file is that we're storing as a binary object. And then of course comes our binary data. Here we can see we've called it, or we're using the medium blob type. So this gives us a maximum of about 16 million bytes. That should be more than enough for whatever we're doing. Now, we need to match this with a bean. So, the primary key and ID, the file name is a string, but for binary objects, we always use an array of bytes. So here we declare that our picture is going to be just that, a byte array. Now, let's deal with how we can turn a file on disk into a byte array. Remember, we're going to need this because when we say we wish to add an attachment to an email, that attachment is going to have to go into the database as well as being sent out to the mail system. So I begin by creating an instance of my picture bean. With my picture bean in place, I'm now ready to work with the file. What we're looking at here is a coding technique used in what's called the new I/O. In new I/O, a path is an object that represents both a file and its location. We create a path object by using the static method getDefault, getPath, and we refer to the particular image. Notice that getPath has two fields. The first field would be a path. In my example, I'm just assuming that p.jpg is in the default folder, wherever that is in my application. Of course, if I want to retrieve it from a specific location, and my application will probably supply me, or not probably, will need to supply me with a open file dialog so I can retrieve files, I would place the path portion in the first parameter. Next step, I need to read all those bytes into my byte array. Let me just move myself out of the way here. And we can see here that I'm using my set picture with the files dot read all bytes. This is a great convenience because what it does simply is accesses the file referred to in the path P and returns it as a byte array, which is exactly what we want. So our byte array now goes into our picture bean, and we finish it up by placing the name of the file into our bean. Remember, our bean had 3 fields: the ID, that's coming from the database, the name of the file, and finally the byte array itself. So my bean is ready. It's time to do something with it. So let's write it to a record in our database. So we see our query here, insert into binary files, and we see the 2 fields, file name and binary data, and of course the matching question marks for the parameters. Remember that we don't use ID here. This will be generated by the MySQL database. Well, time to make our connection to the database, create our prepared statement. These are the only 2 objects we're creating because we're doing an insert. It's only the select that has the 3rd object, typically a result set. So my try with resources simply consists of the connection and the prepared statement. I then add the 2 parameters, the file name and, here we go, set byte. So we have this great convenience, and we simply retrieve that byte array and put it in the 2nd position, execute the update, and we now have a binary image stored on disk. Remember, MySQL doesn't know what it is, what it's for. It simply is allowing you to store exactly what's in memory into your relational database. I've omitted all of the code around this particular statement. We'll see it when we look at the sample project, but I just wanted to point out that when we have a result set and we wish to retrieve that array of bytes, it's simply result set dot get bytes. So let's put it all together now. Here we have what it takes to read a binary large object from a table and then immediately writing it out to disk. You may find that in your application, writing it out to disk happens only when a user wishes to save the attachment to a specific location. Right? We see that there's an attachment. We want to save it. So first of all, let's retrieve it. There's my select name and image from pictures. My prepared statement will now execute using the SQL, and I will add the ID, the primary key. So I'm looking for a specific record. I then execute the query. It returns a result set. I'm searching for primary key, so I'm only expecting 1 record. So I simply look for result set next. If this is true, I retrieve the name. Now, my goal is to save this file with exactly the same name that it was stored with in the database. When we start working with JavaFX and when we work with its built-in file open and file save dialogues, we'll be in a position to select where we wish something to be saved and even change its name. But for now, we're looking at the most basic approach. So given the name, I then create an object of type file with that name. Great. Now I'm going to need to stream, we could say pour all those bytes into the file. To do that, I need what's called a file output stream. I declare that, and I pass it the name of the file. Imagine it's like attaching a hose to a file so that we can pour the file somewhere. Next, I create a buffer. Now, I leave it to you to see if there's a more efficient way of doing this, but right now in my example, I have a byte buffer of just 1 byte. So now I proceed. I create something called an input stream. The input stream allows me to access the binary data from the result set. So just as I had a pipe to a file, now I have a pipe going to the record in the database. And then with this simple while loop, I simply read from the input stream. So I'm reading from the database. My buffer means I'm reading 1 byte at a time. And as long as there was, well, more than 0 bytes, again, it'll never be more than 1, I then proceed to write it back. And you can imagine that this loop is going to work really fast. And eventually, when it's complete, every byte from the database will have been written to the file. With that done, we simply close the input stream, which closes the file, and we now have whatever that attachment was safely on disk. Before we talk about dates, let's take a look at the example code for this. So here we are in NetBeans, and we're looking at a project called File BLOB. Seems like an appropriate name. Start by taking a quick peek at my picture bean. So we can see here, there's my primary key, there's my file name, and there's my byte array for whatever the binary image is. I have a default constructor where I set the file name to an empty string and I create an array of length 0. I then also have a non-default constructor where I can assign all the values. Usual gets and sets. We have it to string, though in this case we're not going to be using it, so I've allowed the standard appearance, and notice I'm only interested in the ID and the file name because I cannot use system.out.println to display an image. My hash code and my equals. Here I've used a technique or an approach that says the way in which I can determine if these two records are the same is based exclusively on the ID. If two records have the same ID, then they must be the same. As you can imagine, you could build something far more complex. You can attempt to create an algorithm that analyzes the image, though I'm not quite sure how you decide if two images are the same or different, if they're close enough. There's certainly enough to think about there. So in my hash code and equals, all I'm looking at is the primary key. So there's my bean. Next thing is I need my database manager. Again, using an interface first, I've created just 2 methods for this example. A create, pass the picture bean, and a find by ID that will allow me to select a particular image based on that primary key. Let's look at the implementation. That's what we're really interested in. It looks very much like what we used previously in our first example of database. There's my URL, though this time it's not fish, this time it's the user and pancake. I come up with these things. And we get to our create. So as we saw in the examples in the slide, given a picture bean and given a query, and we can see here at the end that this query has the 2 parameters, I make a connection, I send the query to the database as a prepared statement, I set its strings. I set the two values. Actually, not strings. The second one is bytes. So picture get file name, picture.get picture, and we say result.execute update. This will now create a new record on disk, and it will contain the necessary, or the image, the binary data that we've come up with. Here's my find by ID. Again, similar to what we saw in the slides. This time I'm only passed an ID, so there's only one parameter that has to be entered. I make my connection. I make my prepared statement. I set the long. So here we've seen something on Tuesday where I end the try with resources so that I can set long or set any of the parameters in the prepared statement. And then I start an embedded try with resources to create the result set. I check to see, was there an image or was there a record found with this ID? And if there is, in this case, because it's such a simple object, I'm doing all my sets in this if statement. Obviously, it would make more sense to put this in a separate private method rather than having this particular method do both retrieval and filling out a bean. I probably said it before, we want to keep our methods as much as is possible to a single task. If I have a method here it is my find by ID. Its purpose is to retrieve a record. The task of assigning the values from that record to a bean represents a second job. And so it is better suited, and that's what I did in my first example, to a private method. Well, let's take a look at dates now. Date is one of those strange topics in Java that has a bit of history. Let's begin though by taking a look at the date or the date types available into MySQL, and then see how we map them appropriately to Java. So in SQL, for MySQL, we actually have 4 different date type fields or date type data types. First is plain date. And in SQL in general, date represents just the year, the month, and the day. Next, we have SQL time. As you can imagine, just the time. We have SQL date time. Date time now combines year, month, day, and time. And notice the range, it's pretty decent, from 1000 AD to 9999 AD. Pretty good range. The only thing though that's missing from date time is any information about the time zone. We sometimes use the word universal time coordinates, a way of expressing time that can be adjusted depending on where you are. So for instance, right now it may be close to 9 o'clock in Montreal, and it's, 6 o'clock in San Francisco. There's a 3-hour difference. If we were able to store time using UTC, the Universal Time Coordinates, this implies that time would be adjusted depending on where you were. In the case of date time, though, whatever the date and time is, it is absolute. So, to deal with that problem, and let me just move myself out of the way a bit, to deal with that problem, we have timestamp. Timestamp, like date time, stores year, month, day, and time. However, for reasons I have not been able to uncover, it has a really small range. Notice it goes from 1970 to just 2038, a grand total of 68 years. Another thing that's noticeable in terms of its difference is that it also includes millisecond field. We can see this right here at the end, the 6 zeros and then the 6 nines. I suspect that the addition of this information is what reduces the available range to us. I guess if you're not doing calculations going back before 1970 or ahead of 2038, this will be ideal. Also, timestamp keeps track of the time zone, and so the time is adjusted based on the home location of the server. So if a particular record is retrieved from a server in Montreal, it would know that it's 9 o'clock in Montreal. But if we retrieve that same record at the same time from a server in San Francisco, it's going to know it's really 6 o'clock in the morning. Next, we move on to the dates available to us in Java, and they fall into two groups. The first group belongs to the java.sql date types. These map pretty directly to the SQL equivalents, date to date, time to time, timestamp to timestamp. Notice there's no date time. Timestamp is capable of performing both tasks. In other words, we would use it for a timestamp, or we would use it for a date time. From here, we take a look at the date types that are part of Java. And of course, we begin with the most common date type, javautil.date. This is an interesting class because pretty much right after it was introduced to the world, the people at first Sun and then Oracle started deprecating it. Date is, for the most part, simply a box. It's meant to hold a long integer that represents the number of seconds from a particular point in time, usually January 1st, 1970. Positive values after 1970, negative values before. However, date does not have any information about time zones. Date doesn't know what to do with a particular situation when the world switched from every city and hamlet in Europe had their own calendar to having a Pope decree that there had to be a standard calendar throughout Europe. They called that calendar the Gregorian calendar. And as different places in Europe adjusted to it, well, literally days disappeared from the year to allow everybody to synchronize. JavaUtil.date doesn't understand that, though I'm not quite sure how often you're going to have to do calculations that go back into the 1600s. Before the more recent Java 8 date types, it was usually recommended that you use something called a Gregorian calendar in place of a date. However, Java 8 introduced new date classes based on a library many programmers used called Joda Time. This approach was made part of Java 8 and so introduced three new classes: local date, local time, local date time. As you can imagine, the first two map neatly, and the last one represents our equivalent of timestamp or our equivalent of date time, but with the added advantage of understanding UTC and time zones. So, let's move me out of the way here for the moment. There we go, I'll hang off at the edge. So let's take a look at how we deal with this in code. First of all, it's important to know how we deal with a date, because as much as it is deprecated, as much as, well, we really want it to go away, the fact is there are many, many libraries that deal with date. So what we can see here is, given an object of type date, and again, remember, the only thing that isn't deprecated in date is its use as a box. So we assume that getIt somehow is returning a date object. The reference is assigned to our date. Now, we'd like to put that date in our database. So we want a timestamp, because normally a date is both days, years, months, and time. So we create a timestamp, And in doing that, we call the getTime method from date. We're calling time because the time portion is, again, the number of milliseconds from a given point. So it actually contains more than just time. With the timestamp set up, we're now ready to put that timestamp into our database. In the second example, we're going the other way. Here, we're retrieving a timestamp from the database, and we're assigning it to a date object. And notice it's really simple to do because timestamp and date form an inheritance. Timestamp is derived from date. Of course, we're not going to use date. We're going to use the current standard for managing date and time, and that is local date time. You're going to find that unless you absolutely need just date or just time, you're going to use either date time or timestamp. And when you wish to deal with it or convert it back and forth between the new Java 8 time libraries, well, it actually turns out to be quite easy. Timestamp, for instance, has a method specifically to allow the conversion of whatever time you've stored in the timestamp and place it into a local date time object. In the other direction, it's also quite simple. We simply ask for the value of LDT. LDT being my local date time object. This value of is supplied with the appropriate information to allow the static method value of to create an object of types timestamp, and we assign it to our timestamp variable here on the left. Well, we're just about done talking about a database, again, because I assume you've done all kinds of good stuff with it. But I just wanted to point out this last chart here at the end. You may find it useful. It allows us to see what are the SQL types, what they're called. Remember in Tuesday's lecture, we talked about metadata. Metadata is data about data. And one of the things we can ask metadata is, what type is this particular column? So here we see the list of strings that would be returned if we made a query through the metadata on a particular column. Of course, the really interesting information is here at the end, where we see how we're expected to map any of this information. Whether it's a bit here, it can either be a Boolean. If it's a single bit, if it's multiple bits, it's stored in a, well, there's our friend the byte array, and so on. I don't have to read this out to you, but if you're not sure what to work with, for instance, here's an important one to remember. Decimal maps to big decimal. Unless we really are not interested in absolute accuracy, we probably won't use float or double. Decimal is always the preferred time. And there's my date objects, and we can see how they map as we discussed earlier. And here's the more common types you're familiar with, var, varchar, char, and so on. So this conversion table at the end could be useful to you. So this pretty much covers everything that I want to discuss about JDBC, right? I know that you've worked with it last term. Our application of database in this particular program is quite simple. We don't have a lot of tables. You'll get a better workout of your JDBC knowledge when we build our e-commerce platforms next term. But you are ready to now work on the JDBC portion of the project. You should be able to create a database, set up the fields, and create the necessary routines to move those email messages, whether the sent ones or the received ones, into our relational database. We need this in place before we can play with the GUI, because the GUI is not going to be any fun unless it can actually do something like fill out the information and put it in the database, then send it out as an email, and vice versa. So get to work on the database, and I should be back here on Tuesday. Oh, and I notice I've only gone 30 minutes, so I think I'll ask Naz to run one more video before you leave. Bye for now.